So this presentation, I put the word primer in it, but really it's not to teach people how DIDCOM works or something. It's more to set kind of a frame of reference, how to think about what DIDCOM is trying to solve, because it will help people know when DIDCOM is something that should be mentioned in the conversation or where it's really orthogonal to what's being discussed. Here's what I propose to cover. So let me start with a definition. This is my own definition. This is not a definition that's lifted out of a spec somewhere. But, you know, if I have to give a 30-second elevator pitch of what DIDCOM is to somebody, this is probably the sentence I would use. And I want to talk about what I mean by several of these words in the sentence. So I would claim that DIDCOM is a framework for safe, structured interactions built atop DIDs. And those words are chosen fairly deliberately. By framework, what I mean is there's several meanings of framework that are common in computer circles. I don't mean framework in the way that like the Zend framework for PHP provides a whole bunch of libraries and whatever. That's not what I mean. I mean a framework in the sense that there's a skeleton that you can hang things on, like the definition there from the American Heritage Dictionary. And specifically, I don't mean that DIDCOM is an API. I don't mean that DIDCOM is an algorithm or a data model or a format. And I don't mean that it's a library or a component. So I'm just checking here to see if there's any Q stuff there. It looks like not. I'm going to keep going. Safe is a very deliberately chosen word, and it means more than secure. If there's one misconception about DIDCOM that I think exists, it's the misconception that DIDCOM is pursuing security. DIDCOM cares about security, but security is a necessary, not a sufficient description of DIDCOM. It's only part of what DIDCOM is trying to accomplish. And when I say safe here, I specifically mean three things. I do mean security. I also mean privacy. And I know that privacy in and of itself is a rich word that has a lot of ambiguity to it. For my purposes, I'm not going to try to define it really rigidly, but some of what I mean by safety is the privacy aspect. But the one that's maybe subtle and not understood or heard very much when I describe it with the word safe might be the word decentralized. I mean, DIDCOM is safe because of certain decentralized properties that it has. It's common for people who are in this working or in this community group to extol the virtues of a particular blockchain, and when somebody who's outside this kind of circle says, well, why do you care about blockchain? We give them a story about decentralization. And maybe you're not a blockchain advocate. Maybe you like, IPFS, or maybe you'd have something that's not really meeting the definition of blockchain. But all of us, I think, resonate to one degree or another to decentralized. Joe Andrew and I are co-editors of the DID rubric that started out as an effort to understand what we mean by decentralized and which values we think we're delivering with decentralized. So I know that this word means different things to different people, and I'm not attempting to define it really carefully, but I do, when I say that DIDCOM is safe, means some things like it's censorship resistant, it's owned by no one, it's resilient, and therefore it can't be hacked in a single place, that kind of thing, which is more than saying it's secure or private. Structured interactions is another sentence or another phrase that means a lot in this sentence. There are technologies that allow people to securely carry on rich chat. many of us use, Slack or Discord or WhatsApp or Signal or whatever. That is secure, but it's not structured, or at least it's only very lightly structured. Primarily, the content is something that requires human intelligence to interpret. Structured interactions in this definition also implies that interactions is a deliberately broad word that encompasses things more than just client server. And this is why I wouldn't use the word API here. And it's more than just invoking something somewhere else. And it doesn't necessarily imply request response. Interactions can involve more than two people. And that's another reason why I chose the word interaction. Then lastly, this phrase built atop DIDs. I think this first sentence of clarification that I added will mean more later in the presentation. So maybe put a bookmark in it a little bit, but I'll say it now. The goal of DIDComm is to help DIDs interact while retaining the properties of their associated DID methods. Now, that's one way of saying the goal. There's some other ways of saying it too, but the goal is not to use DIDs to authenticate people. DIDComm can be used to accomplish that goal. It's compatible with that goal, but that's not really at the center of DIDComm's target. And the operative thing here in that second sentence of what we're not focused on is both the word authenticate and the word people. So when DIDs interact, you may or may not know whether the DIDs are associated with a particular human being or IoT device or whatever. We all know that verifiable credentials are a way to do that. And DIDs are friendly to, or DIDComm is friendly to and compatible with layering knowledge about human identity on top of the underlying channel, but it doesn't require it or assume that it will happen. It helps it happen in a way that I'll describe later, but it's separate from that in many respects. Joe Andrew sent a funny email around telling everybody about DID Snail. This is an example where you get a little sense for DIDComm's attitude towards certain things, because could DIDComm work over the kind of postal service interactions that DID Snail advocates? Yes, absolutely. Could DIDComm work over messages exchanged as Git commits in a Git repo? Yes. And so what you're seeing, hopefully by those two examples, is that the nature of the DID method doesn't get in the way of DIDComm. It's relatively transparent. If that DID method has some virtue to it, we hope that DIDComm allows the method to continue to exhibit the best of itself when the DID is used in DIDComm. The most important characteristic under this built atop DIDs that I have come to care about is this last line. It avoids sovereignty endangering silos. And that's a more controversial statement. This is where I'm going to try to justify some things and get a little bit passionate, but I'll try to explain what I mean by that in just a minute. So this is a long list of things that DIDComm messaging tells you how to do. I'm not going to read it all. You can go back and look at it if you want, but skimming it, you should see that it specifies a fairly large set of things, but none of the things here are things like telling you how to exchange a credential, telling you how to verify the identity of a human, telling you how to apply for a loan or do other kinds of high-level business process kinds of things. DIDComm tells you how to do low-level things instead. And those low-level things can be used to build protocols out of primitives. So, some things that DIDComm explicitly chooses not to tell you how to do. create or use wallets, work with credentials, associated did with a human, move messages over a transport, choose did methods or key types or blockchains, properly maintain relationships, etc. So the reason I have this list in here is so that we're all clear about some things that are out of scope for DIDComm. This is a set of examples of the kinds of protocols that you could build on top of the foundation of DIDComm. When I said you could combine DIDComm primitives and create protocols out of them, these are the kinds of things you could create. So if you could imagine developing some kind of workflow that reports a crime, I'll pick something in the middle on the right there, and you wanted to use DIDs to authenticate the person who's reporting the crime. Maybe that was a characteristic that you cared about, or maybe you intended to challenge somebody for credentials as part of reporting a crime. You could use DIDComm to build a report a crime protocol, and in the middle of that protocol, you could call out to a credential exchange protocol to get proof of something. And in the middle of the protocol, you could call out to a schedule an appointment with the investigator protocol if you had one of those as well. So it's a way of having composable, rich interactions. And the interactions that have been on our mind the most are these first two on the left: issue credentials, prove things with credentials. You can do that on top of the foundation of DIDComm messaging, but that's only a small part of what you could do. Now, I want to talk about my use of the word structured in the definition a few slides back. I talked about structured messaging and secure messaging. I mentioned Signal as an example of something that's like DIDComm in some ways and not like it in others. This is a Venn diagram, and it shows the sphere of concern, or the domain, the problem domain for secure messaging, and then the problem domain for structured messaging. Or maybe the word messaging isn't the right, structured interactions. I've given one example of each part of the Venn diagram, and this is not intended to be exhaustive, but to just suggest the kind of contrast I'm trying to make here. Signal is clearly about secure messaging or secure interacting, but it's not really about structured, secure stuff. Then it's possible to imagine stuff that's about structured interactions, but security isn't really its focus. I think people who work for Salesforce, we have one on the call here, would say Salesforce provides security, and I agree with you. So I'm not trying to diss Salesforce here. I'm talking about the difference in focus. The value of that technology, and like I said, Salesforce is just an example, is focused on what you can automate because you have the structure. Security is a necessary but insufficient condition to accomplish the goals. DIDComm lives in the space where these two problem domains overlap. And I had somebody yesterday ask me a question. I was building a protocol that was supposed to run over NFC. And this protocol, of course, it's like a tap to pay type of a thing. Two devices are within 4 centimeters of each other. It happens in 1 second. And he asked me if I thought there were a lot of cybersecurity risks of man in the middle and stuff. And I said, no. And he said, well, if the security is good enough, why do you need DIDComm? And the answer is, this is an example of this misconception that DIDComm exists primarily for security. Remember what I said before. DIDComm security is necessary but not sufficient to accomplish its goals. So one of the other goals I had in this NFC interaction is that in the middle of the interaction, if I get challenged for credentials, I can prove something. And the ability to structure the interaction about payment, tap to pay NFC, such that on step 7, I can switch over and challenge somebody for credentials is one of the characteristics I wanted in my NFC development project. So just having security would not give me everything that I was trying to accomplish there. Now, this is just a nod, the example of Salesforce. Like I said before, it would be unjust for me to say that Salesforce doesn't provide security, but like I said, there's a difference in focus where the business value is really most interesting. But I want to talk about a subtlety about security next. And this is a subtlety that comes from the scope at which we examine security, okay? Before I get into that deeply, though, I want to suggest some analogs to DIDCOM that might help our thinking a little bit. So you see my statement there at the top about DIDCOM, a framework for safe structured interactions. I've picked 3 other things that this audience might be familiar with that are somewhat similar to DIDCOM in interesting ways. I'm not going to spend deep amount of time on each one, but if you compare my kind of non-scientific definition of these other 3 technologies, you'll see the parts that resonate and the parts that are different. Just like my diagram on the previous slide where I said the focus is different, I don't have the word safe or secure on my line for Swagger. That doesn't mean I'm claiming that when you build on Swagger, you're insecure or unsafe. It means that that's not the focus. That's not where the business value is. You have to have it. It's a necessary condition, but it's not a sufficient condition to deliver on the mission. So the Swagger line, I think people, you might state this slightly differently than I did, but hopefully you're nodding your head a little bit that this is a reasonable characterization of what each of these things might be. One interesting thing to note here is the difference between safe and secure. David Chadwick, when you asked about, contrasting DIDCOM and SMIME, the word safety in DIDCOM's definition is intended to suggest that it has a slightly different set of goals than just pure security. But I think SMIME, it would be safer to say, or more true to say, that the S is an indication that it's focused just on security. Does anybody, I'm just going to check the queue for a second. How are we doing here?
We are empty on the queue at the moment.
Excellent. So. Okay. And I think I'm doing okay time-wise too, but we'll see. So I'm going to now expand on one of these analogs a little bit. I want to talk about Swagger and compare it to DIDCOM. Now, first of all, I like Swagger open API stuff. I have built some things on it in my career that were important, that I'm proud of. So I'm not trying to, in this contrast, pick a fight or diss Swagger, but I'm trying to show you why the difference in focus has some interesting consequences. I drew a diagram here that shows Open API as if it were a foundation. You could argue whether that's actually accurate. Remember my word framework. Open API is like a set of conventions, a methodology, a way of doing things that lets you build APIs. And I gave 3 examples of web service APIs here. The Yahoo Finance one I know has a Swagger file you can download. I think the OpenStreetMap one does, but I went poking around last night and couldn't convince myself I was right. So I might have picked a bad example there. The VC API that this group works on is another example in this same general category, building APIs a particular way. And underneath Open API, I put stuff like REST and TLS, and there's plenty of other technologies that make the web what it is today that Open API just assumes are going to be there. Collectively, the Open API framework as a generic thing and the specific things built on top of it are casually called Swagger by developers. It's not unusual for a developer to say something like, hey, can you give me your Swagger? Or what's the Swagger look like? Or whatever. And they're kind of generally drawing a box around the stuff that's grayed out here and saying, I want one of those, or let's talk about one of those things. And in the same way, DIDCOM has been used as a cover term by people who are working on it in a way that causes a little bit of confusion. And so this is me giving a mea culpa. The precise term for the thing that's analogous to OpenAPI is DIDCOM messaging. There's a formal spec for DIDCOM messaging, and I'll explain a little bit more about it in this, but not a lot. And then remember I said you can use the primitives that DIDCOM provides for you to construct higher level APIs. So Wacky PEX, Wacky DIDCOM is an example of something constructed out of those primitives. And in the kind of diagram I'm showing here, Wacky would sit above it. It's a higher level construct than the raw DIDCOM primitives in DIDCOM messaging. But all of it collectively is called DIDCOM in some contexts. If I had to describe those yellow rectangles on the right a little bit more precisely, I would call them application level protocols. Those of you that know the OSI stack, there's protocols at several different layers, and the point of calling something an application layer protocol is to point out that it's a higher level construct than something underneath it. I'm checking the queue again. Looks like we're not too bad here. Okay, so stop me if you really need me to. I'll keep going here. So I want to talk about a claim that I've made several times, that the world of web service APIs tends to lead to a silo effect. This is not the silo effect that you might think I mean when I talk about it. I'm not saying that everybody is insular and doesn't want to talk to everybody else, and no efforts at interoperability happen, and no efforts at interoperability can succeed. But there's a deep reason why there is an ultimately a silo effect that kind of goes along with the world of microservices. If you think about microservices, that's a unit of encapsulation, and that encapsulation wants to draw boundaries. And what do those boundaries have as characteristics? Well, they have whatever functionality you're going to expose through the API. And that functionality might be represented by the pink vertical rectangles in this diagram. You write an API that does mapping, great. That's in the code that you wrote that is going to figure out what to do with latitude and longitude. But then at the top of that set of code, you need to have some kind of an interface surface. And what you do is you say, oh, I'm going to make some callable URLs, and they're going to all be behind a particular endpoint. And I'm going to choose a particular URL namespacing convention, and I'm going to pick certain kinds of, behavioral expectations about timeouts, and I'm going to version my API the following way, and I'm going to do state management this way, and here's how I'm going to do errors. You make all these decisions, and that gives you what I might call a surface for your API. And the problem is that every surface is different because you combine your choices about all these different things differently in different services. And the other thing that's true about this world is that you have a client and you have a server, and they're different kinds of things. A client isn't a server, and a server isn't a client. Now, you could have a server act as a client, yes, and you could have a client that had a server behind it. But I'm saying functionally, the duties and the behaviors of something that is in the client role are quite different from the duties and behaviors of something that's in the server role. So what you end up with is an analysis where you want to plug a client into the surface that's provided by an API, and you can do that. But the chances that that exact same client can plug into another API are pretty low. Now, you can work on this. You could say, what if all of the APIs, no matter where they were, had the same auth and mechanism? That would be something like OAuth 2 or OpenID Connect. And that is beneficial. But it doesn't make the surface identical across every service that you create. There's a little link down here in the bottom right corner where somebody smarter than me wrote some stuff about authorization patterns in microservices. It kind of gets at this issue. It's an interesting article to go read. But the net effect here is that you can't easily switch a client for service A and a client for service B. And you might say, well, you don't really want to. But the problem is that the unit of security that you're able to achieve, remember I said that there's a little subtlety about security and scope. The unit of security is typically the same as the unit of the API, the scope of the API. If you want to have security on one of these silos and use the same security on another silo, you can try to translate, but you've got all these different dimensions, 9 of them in this example, that you have to translate across. If a session expires in one silo and it doesn't expire in the other, and you're trying to have the security be the same, then you have a problem. If timeouts happen in one and not the other, then you have a problem. And so all of these factors together combine to make it difficult for clients to wander around and just plug into stuff and talk to them. So the goal of DIDComm, you still have these collections of functionality as vertical rectangles, but all of them have the same interface at the top. All of those dimensions, the 9 things in my previous slide, are answered the same way for all DIDComm things. And these things are protocols, application level protocols. DIDComm messaging is the thing that provides this common set of answers to all 9 of those dimensions. So if you have an application level protocol that is built on top of DIDComm, what you know about it is that it will authenticate a particular way. It will deal with the phenomenon of needing to call back the other party a particular way. It will report errors a particular way. It will construct threads and manage state a particular way, etc. The other thing that's important here is that the thing that embodies this logic is a peer of everything else. It could plug into itself or any other thing that is also DIDComm. It might not be able to accomplish a lot of work in the same way that a human being could walk into a building at an office and ask, let's say, a government employee, hey, I want to renew my driver's license. And the government employee could say, you're in the wrong office. This isn't the driver's license office. So plugging in doesn't guarantee you can get work done, but you can at least have a conversation. And one of the things you can do is this discovery thing down at the bottom, which lets you discover what things you can do with somebody else. So you walk into a building as a human being and you say to the government employee, I want to get my driver's license. And the government employee says, you can't do that here, but if you go next door, you can. And lo and behold, you as a human being flexible and intelligent, walk next door and you try the same thing all over again. Well, something analogous to that can be done in the world of DIDComm, where you can plug in and you can say, hey, do you support the following way of exchanging credentials? And they may say, no, I don't. I'm either ahead or behind you in backwards or forward compatibility, or I have keys that you don't support cryptographically or whatever. But you can find that out. You don't have to have the inability to plug in or walk into the office like a human being. Whereas in the previous diagram, you basically can't even start. So instead of client server, you have peers, and everything is a peer of everything else. Now, that doesn't mean you don't have servers and you don't have mobile phones or whatever, but from the standpoint of the technology, they're all modeled as peers, and that's what allows them to have this reciprocal relationship where anything can be plugged into anything else. That has the effect of unsiloing things, because now if you want to start a conversation about, let's say, renewing your driver's license, and then right in the middle of the conversation about driver's licenses, you want to have a conversation about paying for something, you don't have to have a headache about translating all 9 of these things to some new web service with a new context and new way of doing things. All of that's going to be common, and not just your mechanism for authentication will be common, but the very data for the authentication will be common across those 2 interactions as well. I'm running out of time, so let me see if I can finish quickly here. Hopefully you would guess this by the time I get here. DIDComm and Wacky DIDComm, how are they related? Well, Wacky DIDComm is part of this world of DIDComm. Specifically, it's an application level protocol built on top of DIDComm messaging. Right now, there are some other application protocols that do credential exchange built on top of DIDComm messaging. And eventually, when Wacky hits a maturity and adoption point, it should supersede those. What is the relationship between DIDComm and Chappy? Now I'm going to tell you what it looks like from the DIDComm perspective. A Chappy person might also have another complementary way to describe this, but DIDComm thinks about Chappy as being a way to move wallet data between apps or websites that are hosted in the same web browser. And that means that in DIDComm's view of the universe, Chappy is a specialized transport layer. That's not doing justice to Chappy on its own. It's more than a transport layer, but from the standpoint of how it relates to DIDComm, that's what it means. The reason that this particular relationship hasn't been explored more in the community is because the sweet spot for use cases for DIDComm and the sweet spot for use cases of Chappy aren't that close together. There is some overlap, but right now we just haven't hit the parts where we have to work on that really hard. Okay. And then DIDComm and OpenID Connect. What's the relationship there? OpenID Connect is solving an authentication problem, and authentication is one of these high-level kinds of things. It's an application-level interaction, and it's higher level than the low-level messaging. So the relationship between these looks like this. OpenID Connect is a rough analog, feature-wise, to something like Wacky or to the other application-level protocols that do credential-based authentication. Versions of DIDComm. DIDComm v2 is the one that's highlighted with that yellow arrow. For context, there was something that properly should be called DIDComm v0. It was called agent-to-agent communication when it first started. And then there's DIDComm v1, and you can see some of the characteristics of it there. DIDComm v2 and what its current characteristics are. And DIDComm v3 is imagined. We haven't started working on it, but I believe there will be a DIDComm v3. DIDComm v2 is producing a spec that is suitable for good implementation, and it meets the standards for IP management under the JDF, but it is not intended to be described to the world as a standard in the same way that W3C standard or an IETF RFC are described as standards. So the purpose of v3 would be to take this and turn it into a standard. Right now, the intention is to do that through IETF. There is some reason to associate that with ISO. I could get into the reasons why, but we don't know whether that'll happen, but it might. And if so, it would be a joint IETF ISO thing. It could also be a work item under the CCG, but so far we haven't felt like we needed to do that. But it would be interesting to talk about if others do. Last couple of slides and then I'm done. This is a slide that shows the relationship between DIDCOM v2 components and certain things that this group is probably already familiar with in the Jose family. I won't spend a lot of time other than to just say DIDCOM v2 uses a lot of technologies out of Jose stacks. And lastly, my slide about implementations, so that people who are curious about that will have a little bit of information. You see the hyperlinks. Some of these are stale. I know of 2 or 3 on this list that were done, let's say 9 months ago, and the spec has evolved past them a little bit, and they haven't been updated. Others are quite good. There is something from those 4 little rectangles at the right, something from the JavaScript world, something from the Rust world, something from Swift, something from Python, and something from Java that's quite good. So if anybody's interested in experimenting, that's the information. And with that, I think I am done talking, and ready to answer questions.
Awesome. Yeah, much appreciated, and kind of queued myself up there. So question, I know Secure Key's been banging on an implementation side of things. When we think about standardization, obviously, there's typically a multiple independent, reference implementation or conformance to the spec type thing. I mean, who else is kind of signing up to, hammer down that side and, from a version 2 standpoint, et cetera? I mean, how are things looking on that front?
So this is one of the things that makes DIDCOM more of it's not a formal standard that meets the same bar as a W3C standard, because we don't have a formally defined test suite. However, we do have formally checked in test data and scenarios, and we have tested 4 of these libraries and got them to all pass against these tests. And we have a demo that shows libraries from different programming languages and different implementations calling each other. So we haven't done nothing about that, but we probably haven't met the same bar of rigor that we would if we were in the W3C. You
Gotcha.
asked who did it. The ones that are the formally tested ones that have checked in test data and have passed tests are the ones that are under the SICPA DLab account on GitHub. I was working on with the team that did that work, but there may be some others that also have done it. Those are the ones I know about myself.
Okay, cool. That's helpful. I think Ori, you're up next.
Yeah, I think you potentially sort of just answered this, but I've been waiting to start an implementation. I probably would do one in TypeScript, and one of the main reasons that I've been waiting has been I've been following the spec work at Diff, and so I was wondering whether you could comment on when sort of stable permanent URL with a version would get attached to DIDCOM messaging the spec. Thanks.
Yeah, there's a pull request right now against the spec that proposes to change its status to working group approved. And Monday night, we were discussing whether it was appropriate to merge that, and we concluded it wasn't. We still know of 2 or 3 places in the spec where the words to do appear. The to do items are likely to be resolved by a couple of paragraphs of editing in each case. So our goal is to have it at working group approved at IIW. We had it pretty close to that state in at the last IIW, but we ended up getting some interesting questions from smart people, and decided we needed to hold off until we answered their questions better. I think it's much better. The spec is much better and more mature now than it was last October. I would also say, by the way, that I don't feel like writing an implementation of DIDCOM is very common. Ori, I know how creative you are and how productive you are. Maybe it makes sense for you to do that. I'm not telling people don't do it, but our expectation is that a lot of people can just consume the implementations on this list. Every one of these is open source. You wanted TypeScript. There are two up there that are pure native TypeScript, and then there's the WASM build, which gives you an npm install DIDCOM already that you can use if you want it.
Cool. Manu, you're up.
Yeah, if someone can scribe for me. Thank you, Daniel, for coming and presenting today. Every time you do one of these presentations, I learn a lot. And I think it's super useful to understand your specific mental model when you're talking about DIDCOM, right? So I have a hard time kind of putting all of these things together, but you always explain it so succinctly, and I wanted to appreciate you specifically for always doing that. The questions about implementations were really good and super helpful. I'm wondering about, the kind of standardization track. One of the things that I've always struggled with DIDCOM is understanding if DIDCOM is like how different is it from the HTTP protocol? Meaning, like 20 years ago, a bunch of people got together and they were like, hey, let's build this interface that, is called client server, but they tried to make it peer-to-peer, and that has kind of changed over the years. And they tried to create these, sub protocols that could run, inside HTTP. But as you rightly pointed out, we have a whole bunch of microservice silos today. What key thing do you think that DIDCOM is doing differently that's going to ensure that it doesn't fall into that same kind of trap, the intra-protocol trap of building a bunch of microservice things over DIDCOM, and as a result, not being able to interop?
So that's an excellent question and a very important one. And I think that the risk is real. We do have some experience implementing interoperable stuff. We know what it's like to interoperate. The Aries Interop Profile 1 that was associated with DIDCOM circa 2019 ended up having about 10 different vendors. And the vendors used about 5 different underlying stacks. And we achieved some pretty good interoperability, including sharing credentials and whatnot. But we also learned that the spec wasn't tight enough on several places. And I think that could be a source of risk. I would say that the one thing that we're changing here is the hard assumption that everything is a peer. That doesn't mean, as I said before, that you can't have clients and servers or whatever, but it means that DIDCOM refuses to think about things as clients and servers. There's no language anywhere in the spec that describes something as being a server or supporting callbacks or whatever. Although if you understand how a server could behave as a peer and still be a server, you could certainly read that into it. And because the spec refuses to talk about it that way, I hope that it will hold a line. And it's that peer characteristic and the fact that DIDs are the fundamental thing underneath it that gives me some hope. But it's a guarded hope. I don't know that it's for sure going to be a glorious outcome.
Cool. Let me just check queue again. It looks like I am up, so I'm going to close it out with a question. I saw a lot of cool Jose stuff there, and obviously I work on some things in that area, especially post-quantum signatures right now, heavily. Question about Jose. Where are things going there, or are you even looking at the binary side?
So that's one of the things that's been deferred out of V2 of the spec. It was brought up quite a while back, but it is on the table for a V3. So it won't happen in the spec that's about to become frozen, but it is under active discussion.
Cool. Well, awesome. Really appreciate the time today. It was a great presentation. Lot of good info dense, yet kind of getting right to the point. So much appreciated. As always, looking for good ways to kind of increase and embed contributions and communications back and forth between diff and CCG, et cetera. So, I think this was a good aspect of why we can get some cool stuff. I do think that there's probably some good follow-up conversation to be had around, CCG spec or work item type interrelationships with DIDCOM, or ways that they can leverage and or help each other and increase adoption. So yeah, once again, just really appreciated. I know, that's a very mutual feeling from everyone else, and just, want to thank you again. I guess last 30-45 seconds for closing remarks, if you got any thoughts.
I appreciate the time. If anybody wants the slides, the URL should keep working. You can download the slides. At IIW, there will be some demonstrations of some things like we did 6 months ago. But you should be able to more or less get the demonstrations yourself while you're eating a sandwich over lunch one day. Writing Hello World in DIDCOM is pretty trivial.
Yeah, awesome. Cool. Well, much appreciated. I might hit either the Python or the Go implementations and tweak around a little bit myself. And I guess just everyone have a wonderful Tuesday, as Tuesdays always tend to be. And we will talk again next week for those of you who aren't on a work item call with one of us or more of us later. So enjoy your day. So I'm going to stop recording.